Okay, students, we are in the live session 2. So, live session 4, and today is 28th of August, and we are yet to start the live session 4 for the course Physics of Renewable Energy System. So, we wait for one more minute for other students to join this course, join this live session, and then we start. And if there are any queries in between, so you can always write them in the chat box. I can read your queries. I will answer them in between the lecture, or else you can also ask the question in the last. I will give you some time, 5 to 10 minutes, to ask your questions. So can anyone confirm, am I audible to you all? Okay, so yeah, I am audible. So we will start the live session 4. So once again, welcome you all to the live session of this NPTEL. The course is Physics of Renewable Energy System. This is live session 4, and this course is taken up by Professor Amrish Chandra. He is from Department of Physics, IIT Kharagpur. I am Rohit, TA of this course, teaching assistant, and I am taking this live session on behalf of Professor Amrish Chandra and to take your queries, to discuss assignment questions, and to discuss concepts, various concepts that goes behind the physics of renewable energy system. So I expect you all to ask, feel free to ask any questions come to your mind. Even if not related to this course, you can ask this question. We will discuss the questions which you raise. If I know the answers, I will answer your queries, which most probably will happen, or otherwise we will find some better answers to your queries. Okay, so let's start this session. The first question is tidal energy utilizes. So tidal energy. If we see the tidal energy is basically harnessing the energy of tides. This is so simple. But tides are actually a function of the force that is exerted by moon, and to some expect sun also. The moon is nearer to earth, and gravitational force is actually proportional to the distance, inversely proportional to the distance between these two bodies. Like this is earth, this is moon, and this is far away a big body called sun, which provides us with so much of solar energy, other energy forms also. And so if we see the distance, this is moon. If we see the gravitational force, let us write gravitational force as GF. Okay, and this is equal to a gravitational constant, mass of earth, mass of the other body, that is moon or sun in this case, and the distance in between them. Make sure this distance is actually taken from center to center. Okay, so if we are taking this distance from earth to sun, it should be between center of sun to center of earth. So we write this distance as RS square. Okay, so we see that gravitational force is actually inversely proportional to the distance between these two bodies, the square of distance between these two bodies. So you can see if there is less distance, inversely proportional, what happens? Like F is inversely proportional to 1 by L, length. Force is directly inversely proportional to length. So if we increase the length, what will happen? The force will decrease because it is inversely proportional. So here the same concept is being applied. Between distance between earth and sun is more, that is around 15 crore kilometers, if I may be right, 15 crore kilometers. And if we see the distance between earth and moon, it is 3.84 lakhs kilometer. So you can observe the distance, 15 crore kilometers to the 3.84. So whosoever has a more nearity to the earth, that is moon in this case, will exert a more gravitational force on the earth. So this gravitational force actually what it does, it actually make the ocean of the earth or the water body bulges towards, bulging, a bulge is created which we call tides. So it is a periodical in nature because moon has 28 days of rotation, and same it takes to revolve around the earth also. So it has a periodicity. After a specific period, that is around something 6 or 12 hours, this thing repeats. So we always have a tide in after 6 or 8 hours. Okay, 6 or 12 hours I think. So you will have to check whether it's 6 or 12. I think after every 6 hours we have a tide. So after every 6 hours we have a tide, and we can actually harness this energy of tide. So to harness this energy is basically utilizing this energy, because this energy is a renewable source. We are not spending any fossil fuel to recover it or any other thing. This energy particularly cannot be depleted over time. So there are always availability of energy in tides that is need to be harnessed. So the question is, tidal energy utilizes what? The potential energy of water, the kinetic energy of water, both A and B, and none of these. So if we see, tidal energy doesn't have any potential energy stored in it. Okay, it basically that due to the tidal motion, this water actually moves. There are some setups here. This is a reservoir, this is a sea level. So when there are tides, this actually levels increases and this stores in the reservoir. So what happens? The kinetic energy actually helps in getting the water into the reservoir, and then it actually flows back through a turbine. Okay, so that's how it happens. So actually tidal energy basically utilizes the kinetic energy of water to harness it. So you are now clear about this concept. The tidal energy utilizes basically what? The kinetic energy of water. Okay, and one more fact is there. How much is the potential of tidal power available throughout the world, the global potential? So you will be cherished to know that it's 120 gigawatt. That is a huge amount of electrical power. 120 gigawatt. If we compare it with India power, the power generated, electricity generated by India, India is actually generating up to the last year, which I know, something around 386 gigawatt. So 1/3 of the electricity requirements of India can actually be fulfilled from the tidal electricity. And you know this is a renewable source. So what India is using actually to produce electricity? Coal or gas power plant, natural gas. So we can actually substitute this with tidal power, and we can actually save on of our forex reserves also, our, and moreover the emission of pollutants, because if we burn fossil fuel coal, you know how much is the emission of pollutants. So that's how it is very important to harness these alternative sources of energy. Okay, now we move to the next question. So next question is very interesting. If you see, which of the following is not normally associated with hydroelectric power? The concept here is hydroelectric power. Hydro, you know, hydro is a word for water. Electric is electricity. So if we convert water power to electricity, that is hydroelectric power. Okay. So what is not normally associated with hydroelectric power? Low construction cost. It is not a low construction cost. You know, dams are actually thousands of crores goes into building of dams. So we cannot say low construction cost. This is actually, this option is wrong. You cut it down. Low maintenance cost. If you see a dam, okay, so dams are actually very few staffs. You see something around 10 or 20 staffs are actually managing the gates or something. Very low. Once dams are constructed, very less amount of money is required to maintain them. Dams are constructed for some 50 or 100 years, maybe 200 years also. So that's how dams are actually very less maintenance cost is there for dams. produce minimal pollution. That's okay because dams are renewable energy. They are just using the potential energy of water to convert it to electricity. So there are no chances of burning fossil fuels. So this is also correct. Supply both base load and peak load. So we will discuss this concept of base load and peak load. Actually, hydroelectric power is actually associated with supplying both base load and peak load, similar as coal power plant. Coal power plant can provide both base load and peak load. So we will discuss this fact in detail in next slide. Okay. So as of now, you can assume that hydroelectric power can supply both base load and peak load. But what it doesn't provide, low construction cost. It is a very high construction cost project. You have to shift people also. You have heard that many of people are getting shifted from relocated due to the dam building, like in Teri Garhwal, Narmada, the dam or river Narmada, okay, Sardar Sarovar Dam. Um, there are many social activists also who are working on in these issues like shifting, relocating, submersible of agricultural lands, flooding, deposition of silt. So there are many facts, many issues that are associated with dams that adds up to the construction cost also. So what is not normally associated? Low construction cost. So the correct answer is A. Okay, and I've also put actually some facts also. Some facts you should know which are not present in the slides. I thought that it will be interesting to all people. To you all people should know these facts also. So if we discuss these facts, 20% of world electric supply to the current date, if we actually count the electric power supply totally and we see the how much electric power supply is actually done by the dams, 20% of the electric power supply is actually through hydroelectric power. That's a very huge number, very huge number. So if world is actually producing something around 2 terawatt of electricity, so 20% is actually 400 gigawatts. That's a very huge number. Okay, these are actually you actually search for how much electricity the total world produces. I just gave a figure of 2 terawatts. Okay, and don't take it as absolute data. And world largest dam is actually Three Gorges Dam that is built by China with a capacity of 22,500 megawatt. That is huge power. 22.5 gigawatt of power. That's very huge, very huge. Okay, and if we see Three Gorges Dam, I put the figure also. See how enormous it is, how big it is, the amount of water flow. What do you think if you are standing there, what will happen to you? So you will actually get flow through the water process, and maybe we can't even find you. Where are you also? So that's big is this dam, and it is actually on some Yangtze river or something, and that's a very big river. You actually search for this where this dam is located, Three Gorges Dam, and it's a very big dam. Okay, Yangzhou province or Yangtze river or something. Okay, and this is the amount of capacity that this dam actually tends to produce. And the biggest dam in India is Bhakra Nangal Dam. Bhakra Nangal Dam is actually situated in Nangal, Himachal Pradesh. It's in the border of Punjab and Himachal Pradesh. Very big dam with a very high reservoir capacity, very big reservoir capacity. Okay, and it is actually producing around 1325 megawatts. That's also a huge amount of electricity. But if we compare it with Three Gorges Dam, see how much is this is 22,500 megawatts, and this is only 1325 megawatts. So you can imagine how big is this Three Gorges Dam and how big is the Bhakra Nangal Dam, which is already a very big dam. If you go to Bhakra Nangal, even visit Bhakra Nangal, you will see that dam is very big. Okay, and which is the highest dam? Highest dam which I am saying, if you measure it from the reservoir level to the dam level. So highest dam in India is Tehri Dam. Okay, so remember it. Highest dam in India is Tehri Dam, and the longest dam in India is. Can anyone say which is the longest dam in India? You can answer in the chat box also. I can see the chat box. Let me also add some people. Can anyone see in the chat box, or else you can also answer it here? I can hear you. Nobody? Okay, let me tell you. It's Hirakud Dam. The Hirakud Dam is in, let me change the color also so that it's more visible. Okay, the Hirakud Dam. The longest dam in India is Hirakud Dam. It's situated on Mahananda or something. You need to check the river name, Mahananda or something river. Okay, Mahanadi river. Yeah, Mahanadi river. And this is the longest dam. The biggest dam is Bhakranangal, and the highest dam is Tehri Garhwal. Okay. Let me check if anybody wants to join. No one. Okay. So, and we discussed about dams. So yeah. Now the next slides. The next slide is actually I put it up intentionally so that you know actually basically what is base load and what is peak load. So I said that we will discuss this slide, what is base load. So what happens is there is always a load demand throughout the day that doesn't change. It is the minimum demand over a span of time that is always present there. Like if we switch off all the AC, all the fans, but we need lightings, we need fans, we need to see TV. So there is always a demand of electricity that is constant throughout the span of time. Okay, so this is actually drawn over by observing total electricity consumption trend, and this more effort is gone into drawing this diagram and determining the base load. So base load is basically the minimum demand that is over a span of time, and that demand is actually termed as base load. And what is peak load? So you see that in summer, like in after 6 p.m. So after 6 p.m. what you see, all the people come back from offices. We switch on the TV, we switch on the ACs, we switch on the washing machines, wash cloth. So everything is switched on. But we don't use AC always, we don't use washing machine always, but only for some duration of time we switch on these, all the people switch on this. So there is a surge in demand, actually increase in demand, that is seen here. We see that base load is here, and there is a surge in demand. Okay, basically in summer, in summer in afternoon we require AC, we require fan, all these things, fridge. So there is a surge in demand. That surge in demand is actually peak load. So peak load is the highest amount of energy that a consumer draw from the grid in a set period of time. So now you understood the base load and peak load. Okay, and these base load and peak load are very much important to determine or to design any hydroelectric power plants. So what happens, coal power plants are actually much flexible. So if there is a change in peak load, we can always increase the power through here. We can put some more coal and increase the power. If there is less demand, we can put less coal and reduce the power. In hydroelectricity also there is a reservoir there, so we can always make more water flow through the penstock. So penstock, penstock is a long tube through which at the last there is a turbine and it is connected through the reservoir. So we can always push more water through the penstock, and that can rotate the turbine much faster, so more electricity can be generated. And in case of less demand, that is base load, we can put the flow to the minimum or the required one. Okay, so that's how. But in case of solar, what happens? So solar can't be designed for peak load. If we increase the peak load, we cannot put a solar cell just now. Okay, So we design the solar for base load only. Solars are basically solar energy is for base load only. That's why it's not always that we don't have solar cell. That's why solar energy not everywhere to be seen on every rooftop. If solar energy free, why not everyone is using solar? This is the main reason, base load and peak load. It can cater to the base load, a bare minimum load, but it cannot take away all the house loads because it may require a lot of solar cell. It may require a more solar cell than what you have a roof area to be installed. Okay, so that's why solars, and it's always costly to operation and maintenance and the capital investment that goes into the installation of the solar power plants. So we find that getting electricity from grid is much cheaper than installing solar and maintaining that. So that's why it's very important to study this base load and peak load and to design an electricity system or energy systems that cater to these base load and peak loads. Okay. For winter, if we see winter, we have heaters. So also winter, the base load and peak load curve are actually somewhat different than there. In the morning, winter we require more heat because morning the temperature, so it may be like this also. In afternoon, there is sunlight, there is heat, so we may require less power in terms of heater. That's why. Okay, so that's how it changes. So if there are any queries, feel free to ask. If you can also write it in the chat box. I am reading this chat box. Any questions, any queries, if you want to ask, you can always ask. Okay. Now the question 3. What is the shape of velocity profile of a viscous fluid in a pipe? So what is the shape of velocity profile, and why do we need a velocity profile? Okay, viscous, what is viscosity? Viscosity is actually the friction that goes into the layers of fluid flow. So that's how, that's why we need a velocity profile. So what happens if this is a wall? Okay, let's just say a fluid particle here. Due to the wall here and the friction present between wall and this fluid particle, the fluid particle will have a very less velocity, approximately equal to 0. Okay, but as we move away from the wall, there will be an increase in momentum also that will increase the velocity, but always the viscosity in the fluid is there. That will somebody wants to join, let me add him. Okay, who wants to join? Okay. So we were discussing this fluid velocity profile. Okay, so what happens if there is a particle here? So viscosity is there. Due to the viscosity, it actually experiences frictional force, so it can go up to this only. But as we go toward this, the viscosity, because the wall layer which is adjacent to the wall will have a maximum friction, and as we go towards the center, the friction will be less. So that's why fluid particle, the velocity will be more at the center. So if we construct a diagram adding to the velocity profile, putting like this is a center, okay, and this is the tube, the boundary, and if we plot the velocity profile of this particle here and here and here, we see that it's in the form of a paraboloid, a parabola. Okay, so that's why a velocity profile of a viscous fluid pipe is parabolic. These are very important terms that need to be studied in fluid mechanics, and actually when there is a viscous flow, it's very important to construct the velocity profile, because with velocity profile we can actually study the streamline flow, the path line, the trajectory, and many other things. So that's why a very important concept in computational fluid dynamics also. So that's how you know why this is a parabolic shape, because the velocity is here, velocity is 0. Here it will be 0.1, here it will be 0.2, here it will be 0.4, here it will be 0.8. So, this is increasing linear, exponentially or parabolically, you can say. And similarly, it will decrease like this. So that's why it is. And Here if we see what these horizontal arrows represent, so horizontal arrows are actually fluid velocities from the at the radial distance from the center. So at center it will have highest velocity, so a long arrow. If we move here, it will be a velocity somewhat less than center, so a arrow which is shorter than this. So it just a plotting and just connecting all these velocity points. And velocity it is maximum at center because the friction is much lesser, and zero at wall interface because due to friction of wall it will actually hold the particle. So that's why the velocity is zero. Okay, now the question 4. So question 4 is for example of wave energy converter. So what is an example of wave energy converter? Is it flywheel? It is Pelamis energy converter? Is it the Edinburgh duct or all of the above? So to answer this question, you need to know what are these: flywheel, Pelamis energy converter, Edinburgh duct, and all of the above. And I put a figure of Pelamis energy converter also because many people confuse with how it works actually. So I put a figure also. I will discuss the working also so that you can know what is a Pelamis energy converter. And this is the most uh, for harnessing wave energy. This is the maximum or commercially used device, Pelamis energy converter. Flywheel is just a disk. Okay, flywheel is just a disk that stores energy by rotating. Okay, it stores the energy, and then when the speed is low it actually derives the energy. Flywheel can be found in IC engines or many other devices. You have heard of atta chakki, flour mill, so that also has a flywheel. Okay, any mechanical device where we need to store the rotational energy, so flywheel is the best option. It's just a wheel, a simple solid disk. Okay, and Pelamis energy converter is this, a snake like device which works basically on the hydraulic pressure of ram. So I will discuss it very clearly, but first let's discuss the Edinburgh duct. It's simple, a device in the form of this Edinburgh duct. So what happens when there is a wave? Actually this rotates. So there is a generator here and some shafts and other things are also there. So whenever this device rotates due to the wave, there is a wave, so it will push a force here, it will rotate. Okay, so whenever it rotates the generator also. So you know what happens when we rotate a generator shaft? It generates electricity. So that's electricity is actually stored in the electric cables in the seabed and taken to the shore and fed to the grid. Okay, sir, your voice is not clear. Let me check.
It is clear, sir.
Oh, it's clear. Okay, Pavitra, if you can check your earphone or let me know if I can help you in anything. Uh, let's give some time to Pavitra so she can actually manage her earphone. Is it okay, Pavitra? Okay, sir. Okay. If anybody has any query like voice is not clear, he or she can anytime tell me. So I can adjust my mic also. I can adjust the camera so that you can have a better experience. I just want to have a better discussion with you all guys. Okay. So fine. Let's go with. Let me see if anyone wants to join. So that. Okay, no one wants to join. So yeah, we were discussing the Edinburgh duct. So it looks like this. Okay, when you see the picture, and we discuss its working, just like wave energy, it rotates the Edinburgh duct. It look like a duck beak. So that's why Edinburgh duct. Maybe the Edinburgh is the name of scientist who discovered it, made this device. So yeah, this is the device which actually, but this is not very much successful device because we need to put it in place, otherwise it will wash away with the ocean currents, ocean waves. Okay, we need to hold it also. So, and it actually generates very less power. We need to put a lot of Edinburgh ducts to actually connect them in a grid and to extract some useful amount of power. So that's how it works. And this Pelamis converter, a very useful device. You can find a Pelamis converter installed in South Korea, I think South Korea or South Africa. You can search it on Google it always. It actually has some snake like structure, okay, and there are some joints in between. These joints are actually made intentionally. You see there are joints here, joints here. Let me change the color of pen so that isn't yellow should be fine. Okay, so you can see the joint here, joint here, joint here, and the cut section is actually shown here also. So what happens when this wave is come? So waves are like this, okay. So this Pelamis converter is also like this, plays on the waves. It has the property, due to the joints it can go up and down, up and down. So what happens, it goes up and down. So there are fluids in the hydraulic rams. These fluids are actually, when it goes up, so it will go, the ram will, piston will go this side, so fluid in this ram will go down, and it actually flows through the turbine here and rotates the turbine, so electricity is generated. And when this goes down, so what happens, this will pushes this fluid in this direction, so it will flow in this direction. So you see it again rotates the turbine, the electricity is turbine generated. So it's basically a hydraulic ram coupled with some snake like structure, so that, and turbine, so that electricity is generated whenever we have a wave. It's just a motion of wave that is converted to electricity. It's better if you can view this on a YouTube video, because it may not be clear by this diagram. So I request you all guys to go to YouTube to see how it works. It's a very beautiful device and very useful device to generate electricity from a wave, okay. So we got this device installed in South Korea or South Africa shore. Also we need to tie up this device on the bottom shore, otherwise it will wash away with the shore and go to the deep ocean. We cannot collect it again. And it's actually a heavy, it's not so it's a bulky also, it's not so much simple like this. It's a very big device, okay. Maybe length, it can have a length of 20, 30 or 50 or 100 meters also. That's how it is. And diameter, maybe I think 2 meter or 3 meter dia is there, and in between this hydraulic ram thing is there which generates electricity, okay. So example of wave energy converter is this Pelamis energy converter, and this energy Edinburgh duck. Okay, let me change it to some other color, I could not see it. This color will fine. Now I can see the pointer, okay. So Pelamis energy converter and the Edinburgh duck, these two are very important device to convert the wave energy. So correct answer is B and C. Now the next question, tidal range can be affected by. So I put a very beautiful animation how the tidal energy can be harnessed. For this I will explain this also. We will have a discussion if there are any queries. Let me check if anybody wants to join this session. No one. Okay. So tidal range can be affected by. So you know tides. Tides are. Somebody wants to join it. Let me check. Who wants to join? Because okay. You know, in the first slide we discussed about tides. So how tides are actually inversely proportional to the distance between two very large bodies. So you know, tides we discussed as sun, earth and actually moon works in tandem to generate tides. So tides can be affected by sun gravitational attraction, This is a correct option because sun actually very less force is exerted by sun, but it exerts force on the earth also. So sun gravitational attraction is also a factor that tidal range can be affected. Also, you will see the topography of the coastal location is also a very important factor. Topography. What is topography? Topography is simple landscape of the coast. So if there is a bulky some bulging landscape, so it will actually take away the energy in the tides. So we cannot actually harness much energy here. But if it is a plain landscape, so tides will be like this. We can harness energy. Much height is there. Much kinetic energy is stored. So more kinetic energy, more converted to electricity. So that's how it works. Depth of the ocean, yeah, very much. Depth of the ocean, you have actually seen in the slides also. Sir has actually explained very beautifully how the depth of the ocean actually explains the lambda, the wavelength. So lambda by 2 or something. So you should go through these slides also. He has very beautifully explained and mathematically derived all the expressions for this tidal energy. Okay, so depth of the ocean actually also affect the tidal range. Rotation speed of the earth, no, rotation speed of the earth doesn't have any effect on the tidal range. Only the distance between earth and moon, distance between earth and sun, the topography of the coastal location, and the depth of the ocean has effect on the tidal range. Okay, rotational speed, if you increase the rotational speed, it doesn't have any effect, or decrease the rotational speed, no effect. Okay, so that's how the correct answer is A, B, and C. Now we have a numerical. So we have three numericals here that are very important to discuss, that will give you a great idea how much energy can be generated. So if you are working with water wave, so you should know actually if there is a wave of 10 meter, how much energy we can harness from this wave. So we will actually, what are these numericals for? These numericals are for only these things, to know how much power can be generated. You should have an idea. So if anybody asks you if there is a wave of 1 meter, how much energy you can harness, so you should know these concepts very importantly and very clearly. So I have actually put three important numericals to discuss these concepts, and we will discuss not in one by one. We will discuss one numerical, so you don't feel a very numerical based session. We will discuss one numerical, then one concept here, then another numerical, then another concept here, then the last numerical. Okay, so you actually feel interesting. Actually, solving too much on numericals are actually very much boring in the class. So I want you that it should be a very interactive session. So the first numerical, it actually says calculate the power generated by water waves. So power generated by wave. Okay, height of the water wave is 10 meter. So you know the height. Density of water is 1 kg per meter cube. Wavelength of water. Wavelength is actually, this height and this crest. So it's between the two crest. The distance between the two pitches are actually, or distance between the two crest. This down thing is called crest, bottom thing. Okay, so waves are like this. So distance between two pitches or two crest are called wavelength. Okay, so that's why wavelength of water wave is 100 meter. Value of acceleration due to gravity is 10 meter per second square, g value. So how much is the power generated by the wave? So power is basically equal to 0.5 into rho into g into h square into 1.2 into g into lambda by 2 into pi. So this is a fundamental formula. We just put the values here. This formula actually derived very beautifully in the slides also. You can go through them. If there is any queries, you can always ask them on discussion forum. So these concepts need to be cleared, how this formula has to be applied. So power equal to 0.5 into rho. What is rho? Rho is density, which is given 1 kg per meter cube. G is acceleration due to gravity, which is given 10 meter per second square. H is actually height of water wave. We have given height of water wave 10, and lambda is 100 meter wavelength. And what is pi? Pi is a constant whose value is approximately equal to 3.14. Okay, so we just put all these value 0.5 into 1 into 10, 10 is g, then we know 10 whole square, that is h, into 1 by 2, this whole thing is bracket, into square root of 10 into 100 upon 2 into 3.14. Okay, so that's how this is calculated. So how much is this if we calculate all these things? Let me calculate also. You guys also continue and answer in the chat box. I want to see who calculates first. So 0.5 into 10 into 100 into 5, it's 250 and okay, it's approximately equal to 3150 watt, the correct answer. Okay, so you guys also calculated how much is the correct answer? 3150. Now you got it. How much is the wave power generated by a wave that has a height of 10 meter? So a height of 10 meter can generate 3150 watt. That's a good amount of power. 3150 watt if you compare with electrical devices. So a room electric heater is around 1000 watt. So you can actually run 3 of these room electric heaters in winter in 3 rooms with this 10 meter height of wave only. Got it? So you know how much water wave is important and how much power it can generate. Now we discuss a concept, then we go to another numerical, and you find it to be very interesting. The numericals are very interesting, like solving how much water wave, how much power is contained in the water for hydroelectricity. These type of numericals are there. Okay, so why wave power is yet to contribute significantly to the global energy? So this is a very big question. If wave power, you see that 10 meter of wave can actually run 3 of the room heaters in winter. So why it is not significantly contributing to the global energy? We see that we burning coal or hydroelectricity or solar energy, wind energy, but not wave power. Why? So actually what happens, ocean is a very harsh environment, actually very harsh. You know, a lot of big waves are there, lot of wind is there. You can, if any of your friend is in merchant navy, you can ask him how much harsh is ocean. Ocean can be as calm as a monk and as raised as a bear. Okay, so oceans are very powerful. So tapping energy from ocean is very difficult. If you put a device here, a tsunami will come, this will carry away the device with it, and these devices are actually very costly to put up. So this is a simple harnessing wave energy device. So it actually goes up and down, and due to the motion, this motion of up and down, this turbine rotates, and a generator is there which actually generates energy which goes through the seabed cables. So this is a simple device to harness wave energy. And tapping energy from ocean is difficult, that is one thing. Another thing is extremely large waves on the rare occasions. So like tsunami has a very big wave, big waves. So what happens, these it will actually damage the devices also. It can make it sink in the ocean also, damage the, even a small electronic equipment is damaged there. So we need to go there, we need to maintain there. So operation and maintenance cost is also high for these devices. Corrosive nature of salt water, this is a very big thing. You know, salt waters are very corrosive. You put a iron rod in the normal water, you put a iron rod in the salt water, you know, the iron rod in the salt water will be corroded very much easily, very much in less time than normal water. Equipment should withstand such high force, very high force in ocean. So we need to search for materials that can actually, materials like composites, polymers, nanocomposites, or toughened steel. So these materials are actually costly, and we need equipments of these materials so that can withstand high force in the ocean. So that's why there are so much of things. It actually adds up to the cost of installing it, that is cost called capital cost of maintaining it is called maintenance cost of operating these systems are operation cost. So due to high cost, it actually we say that okay, we go for wind energy or solar energy, not for tidal energy. But in future, if we can put make some innovative devices which are very less costly than solar power, solar devices, and can harness more power, so certainly all the companies will work in direction only. So that's why, that's how the research, the technology, the engineering, the science which goes behind this, science is very important thing that goes behind it. Energy applications, science is the real thing that goes behind designing these things, okay, to understand the nature of these things. Now we discuss next question. So this is a simple question. It only asks the angular, calculate the angular frequency of rotating ball. So consider ball is rotating around an axis. Let there is a ball, so it is rotating around an axis having a linear velocity of 20 meter per second. Okay, and associated wavelength of rotation is actually 5 meter. Then what will be the angular frequency of the rotating ball? So it actually, if something is rotating around, this ball is rotating. Or somebody wants to join. Let me see. Admit. Okay. So we were discussing that if the ball is actually rotating, so what happens? We need to calculate the angular frequency of the rotating ball. So angular frequency is simple thing, 2 into pi into linear velocity upon the wavelength. Okay, and we know the linear velocity is 20 meter per second and the wavelength is 5 meter. So we put the values here, we calculate 2 into 3.14 into linear velocity 20 upon wavelength is 5. So when we calculate it, we actually get 2 into 40 into 120 by 5 is something around 25, 24 point something nearby 25 second inverse. Okay, and make sure you know the angular frequency is in second inverse, the units are correct. So the correct answer is B. And why do we need to know the angular frequency? So these are actually very important when we considered wave energy. So if we put a ball here, so when wave will come, this wave will actually push the ball above, and then when wave will pass, this ball will go down. So that's how it works actually, and that's why if we trace the path of this ball, it will actually move in like this, in a circular path, due to this wave. Okay, so that's why we need to know the angular frequency, the related fundamental formulas, need to know the calculation, how to calculate the angular frequency also. Now let's move to the next slide, the last numerical. So it's a very important numerical. Calculate the power of falling water. You know falling water, where we do have falling water in hydroelectric power. So calculate the power of falling water, and if the density of water is 1000 kg per meter cube, flow rate is 2 meter cube per second, acceleration due to gravity is 10 meter per second square, and head of water is 1 meter. So how much is the power of falling water? So falling water, if this is a dam, this is the reservoir. Okay, now let's consider it in terms of dam only, and this is a turbine placed here. This passage is called penstock. Okay, you should know the terminologies, very important when you design a dam or you discuss the hydroelectric power. Otherwise people will say pipes, channels. These are not channels, these are called penstocks. Okay, so this is a reservoir, and that's how a turbine is placed here. So water passes through this penstock, rotates the turbine and passes to the other side of the flow. Okay, so we know how much is the water density. Rho is 1000 meter per kg per meter cube. Flow rate is flow rate through the penstock is 2 meter cube per second. Acceleration due to gravity is constant, 10 meter per second square, and head of water is 1 meter. What is the head of water? So it is the distance from the turbine to the upper surface of the reservoir is the head of water. So head of water is 1 meter. So how much electricity is produced? We use this formula rho g qh upon 1000. So rho is 1000 kg per meter cube, g is 10, q is 2 meter cube per second, h is head of water 1 meter, and we divide it by 1000 to get the values in kilowatt. So we just put it 1000 into g is 10. How much is q? 2. Head is 1 by 1000. So 1000 is crossed. We need 10 into 2 into 1 is 20. So how much power is generated? 20 kilowatts. So only a 1 meter head of water flowing with a flow rate of 2 meter cube per second can generate 20 kilowatt of power. 20 of the room heaters. So you could get how much is the capacity of 1 meter of water. If this, in what happens in dam? In dams we have hundreds of meters of water. Okay, that's why the capacity is in 200 megawatts, 250 megawatts, 125 megawatts. Such high capacities are there for dams. Now we discuss, this slide has been discussed, wave power. Now we discuss the last slide, geothermal energy. So geothermal, what is geo? Geo is earth. Thermal is heat. So what is geothermal? Earth plus heat. That is, heat coming from earth is harnessed to in form of heat or electricity. That is geothermal energy. So these are of two types, shallow geothermal and deep geothermal. So if we harness energy from few or tens of meter, like 10, 20 meter, like the height of well, the depth of well, or normal well, okay, normal regular well, or some meter more than that. So it's shallow geothermal. And if we go as deep as 1 kilometer, approximately 1 kilometer is very deep inside. We could how much is Mariana Trench? It's 12 kilometer around depth, 11 or 12 kilometer. So it's very difficult to go to Mariana Trench because pressure will be so much high that our body will burst. We don't have such high. We have such high capacity vessels which can humans can placed in that vessel, and that vessel can go that deep. But it's only the vessel that can withhold such high pressure and force of water. Okay, so going deep is very difficult, and that deep geothermal is 1 kilometer. So the difference between shallow geothermal and deep geothermal. And also I put similar power plant also, if there is a geothermal power plant. So how does it work? So power plant works on steam turbine. So it actually takes the hot water, converts it, this is a steam converter too, it converts it into steam because there is a hot water coming from the earth itself. So we need to provide very less energy here. Okay, so it is converted into steam. How much is the temperature required for conversion to steam? 100 degrees Celsius. It passes through the turbine. Then turbine is coupled with generator. It actually produces power, electricity, which is fed to grid. The steam is then passed through this cooling tower. It is cooled and then it is injected back into the well, where it actually absorbs the heat of the earth. Then it again get heated. It again get trapped in this, gets sucked in this. Then this whole cycle repeats. That's how a geothermal power plant actually works. So this is taken from United States Environment Protection Energy, and they are actually working. United States is actually working on lots of geothermal energy power plants. So they actually want to harness geothermal energy and I think Yosemite National Park, you must have heard. It has some plants or some geothermal springs that can be that United States of America is actually thinking of harnessing. So that's how a geothermal energy works. So that's how the end of this live session, and it was a very interesting session. We talked about hydroelectricity, we talked about tidal power, we talked about wave energy, we talked so much of concepts, we discussed numerical also, a lot of things we discussed. So it was a very interesting session, and thank you all for participating in it. If you have any queries, you can raise those queries now, or you are always free to ask them on discussion forum. I will go and answer each of their queries related to this lecture. And if you have any other queries, you can always write an email to me. This is my email ID. Okay. So if there are any questions, you can.
Sir,
Yes.
sir, I have some doubt.
Yeah,
Uh,
sure.
how the yeah, how the exams are conducted for this course? All the questions will be MCQ, MSQ, or written also.
Okay, so there will be a total discussion, actually announcement there, where it will be written in the rules. The rules of the exam will be written. You always check the announcement forum of the NPTEL. Okay, there is an announcement tab there on the above. So check always. And before the exam, there will be a set of instructions how the exam will be converted. Mostly the exams are MCQs, multiple choice question. Mostly, okay, there may be some numerical questions also, there may be some subjective conceptual other questions also, and the questions are mostly based on the slides, the lectures which we discussed, and some of the questions are actually based on assignments also. So go through previous assignments, like the previous assignment questions are actually discussed by me here also. I discuss some important concepts also, so that you guys can know. If there are any other things to be discussed, you always can write an email to me, like, sir, please put this in the next class, next live session. So I will discuss that also. Okay, and don't worry about the
Yes,
exam.
uh, I
Uh-huh.
have talked with a person who had appeared, and he said the exam pattern varies from course to course. That's why I'm asking about this.
It varies from course to course, and there will be detailed instruction regarding this also. It actually decides by the professor, Professor Amrish Chandra. So he actually decided how the exam will be taken. But be sure it's a MCQ type exam. Okay, mostly it is MCQ. 100.
Yeah,
I can't say
he said
100% because I am not
he
the
said
professor. Okay. Any
because
queries?
he said he typed in computer, in so one should good in typing also.
Uh, no, if there will be a type.
If we need to type in
No, no,
computer.
no, 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 no. I don't think there will be a typed question. So wait for the instructions. Very less chance that you will have to write the answers there. If there are answers to be written, it should be written very briefly. Okay, very briefly, one, two line or three line maybe. So I can't be sure on that. So you can wait for the instructions for exam. Okay.
Okay, yes.
Okay. Any other queries? So yeah, I can read the chat box. Tamijan, thank you. Kartika Ravi, thank you, sir. Justly, thank you, sir. Thank you all, guys. So it was a very wonderful session with you all, guys, and I hope I will see you all, guys, in the next live session 5 also. Okay, I end this session here.
Thank you, sir.
Always welcome.